run too late here. Welcome everyone to our December Alaska Hydrogen Working Group meeting. We're thrilled to have you all here today. This is our last meeting of 2023. Just as a reminder, we will not have a meeting in January since the first Tuesday of the month, I believe, is either the second or third or a date when many might not be available. So we'll skip the January meeting and reconvene in February. So without further ado, we like to always start with introductions. And this is a chance for folks who maybe have not joined our meetings before or who have joined and not introduced themselves to introduce yourself to the group. And let us know where you're calling from. It's a friendly group, nobody bites. And so if you're new here, please let us know who you are and how we can connect with you if we have some overlapping interests in the hydrogen ecosystem. Do we have anyone here who hasn't been on the call before?
Aaron, this is Abraham Amoli from Sandia National Labs. Good to see you. I don't think I've been on this call, but I've been in several hydrogen-related meetings in Anchorage, and the latest one was with the Hydrogen Charrette, that was organized by Launch Alaska, with the Port of Alaska project.
Thank you, Andrea. It's great to see you here on the call. Andrea is calling in from Sandia National Labs, has been a technical player in the space for a while. We're really happy to have you here. So we ask folks who introduce yourselves to put your name and contact info in the chat so people can connect with you if you're willing to do that. Brittany, I see your hand up. Please introduce yourself to the group.
Yeah, thank you. My name is Brittany Smart, and I'm the Energy Transitions Initiative Coordinator here at ACEP at the University of Alaska Fairbanks. I work with a few of you on the call here, but this is my first hydrogen working group meeting and just mostly here listening to catch up and get up to speed. Thanks.
Awesome. Thanks, Brittany. And if you wouldn't mind putting your name and contact info in the chat, people can follow up with you as desired and as relevant. So Mr. Bendis, please introduce yourself.
Yeah, my name is Matt Bendis. I'm with NSTAR Natural Gas. I'm the manager of transmission operations. And just kind of curious to see what's going on today with hydrogen.
Terrific. Thank you. We appreciate you being here. Please put your name and contact info into the chat if you're willing, so that folks can connect with you later. Mari, please introduce yourself.
Hello, I'm Mari. I work at Alaska Center for Energy and Power, and I thank Patty for letting all of us know about this meeting today. I had not known about him, so I'm excited to participate or to learn. I'm here to learn, like Brittany.
Learn and participate. Thank you, Mari. And if you're willing, please put your name and contact info in the chat. That helps us let you know about future meetings and also allows others in the group to connect over shared interests. Sarah, please introduce yourself.
Awesome. Hi, everyone. So my name is Sarah Alcadi. I have a process engineering background, but I work in business development for Stormfisher Hydrogen. We're a green hydrogen developer. We do projects all across the US, and I got introduced to the working group through Tim, who I met at the Sustainable Aviation Fuels conference. So I'm just here to get up to speed on hydrogen projects in Alaska and like really excited to learn more and be part of the group.
Terrific, terrific. And Sarah, I'm guessing you're not calling in from Alaska, is that correct?
Yes, that's right. I'm actually calling in from Canada, from Alberta,
Yeah.
Canada. Yeah.
Alberta, Canada.
Yeah.
Wow. Calgary by chance?
Yes,
or?
that's right.
Okay.
Yeah, that's right.
All right. Well, welcome to the call.
Awesome.
I think all of our previous folks were calling in from Alaska, but it's always interesting to hear where people are tuning in from. So welcome. We appreciate you being here today. Please put your name and contact info in the chat so folks can follow up with you and we can send you future updates as relevant. So
for sure. Thanks for having.
Yeah, thank you. Any other new faces, new people who have been on and maybe haven't introduced themselves previously? We'd love to hear from you and hear what your interest is in the Alaska hydrogen conversation.
Hi, my name is Robert Wiley. I'm based in Houston, in Texas. I've background in oil and gas for quite a long time, background in physics as well, new technology commercialization, working on getting myself up to speed on energy transition, carbon capture storage, carbon capture utilization, hydrogen, and I've been watching and listening to your recordings, learning a heck of a lot. As you might hear, my background is not just Texas, but it's also Scotland. And so I've got quite a few connections over there as well. So I'm looking to see what we can do to help out across the world.
Great.
Thank you, Robert. It's wonderful to have you with us. Did you say what your affiliation was, Robert?
I've got a small company consulting, but generally I'm mostly on my own.
Okay, great, great. How did you find out about the group?
I caught up on the ACEP or the the microgrid courses from the UAF. And then when I started searching into hydrogen economy, I saw this and that caught my attention. And
Wonderful, wonderful.
To catch up and see what you're doing.
Thank you. Please put your name and contact info in the chat if you're willing to share that information. Do we have any other new attendees?
Yes, my name is Dave Clue, and I'm with, I'm going to start my video here in just a second. There we go. I'm with Micronuclear LLC. We're based in Tennessee, but I am also a member of the Nuclear Working Group with ACEP. And I think that the marriage between the micro reactor technologies that are out there, not just ours, but the rest of them as well, have a direct link with producing hydrogen. In other words, supplying the heat and electricity that is needed for hydrogen production plants. So I have a decided interest in the working group here with hydrogen, and I thought I would participate today, and I appreciate the opportunity. Thanks.
Wonderful. Thank you, Dave. And did you say where you were calling in from?
Yes, Micronuclear LLC. I'm actually based in Black Diamond, Washington, which is about 35 miles southeast of Seattle. But I'm very familiar with what's going on up in Alaska. We participated in the Eielson Air Force Base pre-proposal conferences. Micronuclear was looking very seriously about submitting a proposal for Eielson, but we just figured that it was not ready. That proved to be the case. I think you guys know that, and we'll be listening in on the presentation with the Nuclear Working Group next month, but or actually next week. But with respect to hydrogen, yeah, I'm very familiar with what's going on in Alaska. We've been following the processes up there. I have family that lives in Anchorage, so there's kind of a family interest in seeing what's going on in Alaska as well. We think hydrogen is a very, very important answer to our emission-free energy future because of the way that it can be used in various types of applications, including internal combustion engines.
Wonderful. We're glad to have you with us today. Please put your name and contact info in the chat so that folks can follow up with you and we can keep you updated.
We'll do that
with future meeting notices. Lots of new faces. This is great. Do we have anyone else who's new or maybe has been shy in the past?
Yeah, this is Ian Zhang from UEF Petroleum Engineering. And, we just finished a proposal to the NSF Energy Research Center in July on the green hydrogen generation from Alaska methane. But unfortunately, it's rejected. I came here to learn more about is any possible to resubmit the proposal. And in that proposal, we found some partners from Australia, England, and a lot of from US universities. It's a good proposal, but we still focus on the Alaska methane convert to green hydrogen. And I focus on the hydrogen geology storage. And recently, we got a lot of good equipment from a Japan company to study the hydrogen storage in the depleted gas reservoir, including the diffusion and the safety leak. It's good equipment. They will arrive in March next year. So hopefully we can find more opportunity to study the hydrogen storage in Alaska. Thank you.
Great, thank you, Dr. Zhang. Would you mind putting your name and contact info in the chat for folks to connect with you
sure.
later?
Yeah.
And just FYI, I don't know if you're interested, I'm having a hard time seeing all of your face there. If you want to adjust your camera, you've got a really good view of your ceiling. So I'll blur you, don't worry, that's okay.
Which camera I'm using? Okay, yeah.
I don't know which camera you're using.
Okay.
All right. Thank you for joining us. Yes, go ahead and put your details in the chat. We would appreciate it. We're really glad to have you here. Any other new folks joining us today?
Yeah, I don't know if I'm new, but I probably missed the last couple of them. I just thought I'd point out I'm Darren Westby, manager of engineering at AVEC, and we always have a vested interest in different opportunities to offset our diesel consumption in all of the villages that we have. We burn over 9 gallons of diesel fuel a year. So any opportunity that we see, such as this, is a great way to learn and see where it goes from here. So just thought I'd say hi. Thank
you. It's great to have you on the call, Mr. Westby, and great to have a representation from AVEC. Please put your name and contact info in the chat so we can follow up with you and make connections as relevant. Any other new faces? Okay. All right. With that, then, we usually take this time to just provide some updates on various focus efforts in the group before we launch into our main presentation. I will kick this off by providing an update on the Hydrogen Opportunities Report. I will admit I was hoping we could say that it was all done and share it today, but the editing process has taken a bit longer than we anticipated, both for content as well as editing for style. I think we can have it to you by the new year. So we will be working on that. We are still working on it. And I want to thank everyone again for their comments during our public comment period in October. We got a lot of good feedback, and that's one of the reasons it's taking so long, as we're chasing all of that down and making sure that we incorporate many of those excellent comments. So still in process. If you are interested in seeing that early draft that we circulated for public comment, please contact myself or Patty Egan, who is our facilitator on the call here, and we will get a copy to you with a caveat that it's undergone a number of revisions since then, and we'll get an updated copy out soon. Doug, I see your hand up. What's going on?
Muted, Doug.
Doug, I think you're muted.
Oh, thanks. Yeah, I was wanting to make one more comment out of that last series of comments that I made that I forgot. I think is extremely important, and that is that if we're going to be successful, one of the things that's going to be really important is scale. How quickly we can scale and how effectively we can scale here in Alaska. What I'm finding is the opportunities that are out there, the companies that I'm talking to that want to come to Alaska have a pretty specific time frame, and if we can't scale quickly, we're gonna miss the window. So that's another, I think, important takeaway from what I see, and as we look at putting that information together in our report.
Okay. Do you mind sharing any further specific information on the time frame that you see as relevant for us, Doug?
Well, sure. Many of the companies I'm talking to are talking in the 2029-20 timeframe, and they're looking at offtake agreements for low carbon electricity and the minimum of a 250 megawatt bites. So we're talking significant increase in the load in Alaska. And, we're hoping to play a real role in that. But boy, we've got to get going to meet that time frame.
Okay, and I think I heard 2029.
2029, 2030, yes.
Okay. All right, well, thank you for that addendum. We appreciate it. So yes, the report is in process, and that was Doug's additional comment. One of the focus efforts before, I will just send a quick reminder out. If you're not speaking, please mute your camera, because if you make any little noise, we get to see a picture of the room you're in, such as Mr. Johnson's room right now. So the other focus effort we have is around methanol engines. JR, I know that I always ask you, and I always feel a little bit bad about this because I know it's you're working hard on it and maybe don't always have new and exciting updates, but is there anything you want to say about that today?
Probably not anything worthwhile for the larger group, but I if you've got some time to catch up offline on it in the over the next couple of weeks, I think that would be good.
Okay, noted. Appreciate that. All right. We will do updates again. Well, actually, let's just see here. Are there any other announcements about hydrogen happenings from the group here? Maybe developments, projects, anything like that before we jump into our presentation?
I've got a interesting thing that I'd be willing to share, Aaron, if
Yep.
It's okay. I've got a visualization that I think would help. Let me just pull that up real quick. I just got permission to share this today, so we kind of had to share with the group.
Okay, and this is Justin Freeman from Kaufman Engineers.
Yeah, sorry, Justin Freeman. I'm our corporate vice president for hydrogen and carbon capture, based in Anchorage, Alaska. So are folks seeing my screen?
I see, yes, your presenter view.
Okay. So we have been, I think I've mentioned in some previous sessions, we've got a pretty strong relationship with Nel Hydrogen, and we've been working with them for over a year on their proton exchange membrane stack module. So this is just going to the market. They've shared that at some conferences, but it takes 8 of their cell stacks and puts it in a modular format where we've got controls, and it's able to produce up to 4,300 kilograms per day. And then lots of things going on in scaling this technology to 20, 100 megawatt systems. I don't have anything to present today on that, but this is it's a new product that we're pretty proud of having a hand in creating, and I think it's going to help scale the hydrogen business to help drive down costs as well, by getting a repeatable design, modular design that companies can use in their planning and to scale green hydrogen. So I thought the group might be interested in seeing it.
Excellent. Do you have any initial deployment plans for that?
There is a lot of deals that are being worked right now. Nothing public at this stage, but we are starting the first build of one of these units for kind of serial number 1 soon.
Excellent, excellent. Well, that's really exciting. Any quick questions for Justin there?
Yeah, Justin.
Aaron, this is Andrea.
Alaska.
I see a hand up. I'm going to go with a hand up first from Andrea.
Yeah, thanks, Aaron. So I was just wondering, what is the ability of this system to ramp up and down?
Yeah, great question. It's got the ability to turn down to 10% of capacity, so 10 to 1.
And how quickly can you do that?
It's pretty dynamic. It's got an ability to kind of fast follow. So a lot of projects that we're working are trying to kind of deal with the intermittency of the renewables with the PEM installation and kind of do base load with alkaline. So we're kind of seeing a mixture of technology on the electrolyzers, which is kind of interesting too, right? Is kind of mixing the type of technology to deal with the kind of the base load versus variability. So the PEMs are great with variability.
Great, thank you.
Okay, I think I heard Doug trying to ask a question. Was that the case?
Yes, and I'll raise my hand from now on. Justin, question for you. Is serial number 1 going to be deployed in Alaska?
It is not.
Okay.
That's about all I can share on that one.
Okay.
Thanks.
Okay. Justin, I wonder if you wouldn't mind putting your contact info in the chat there for folks to follow up with you with additional questions. That might be the best way to proceed here. Thank you.
Okay.
Appreciate it.
Yeah, no problem.
Okay. Any other announcements, developments, projects, cool things related to hydrogen?
Tim Leach.
Thank you. I'm just trying to find my raise hand button other than the old manual one. So for a couple quick project updates for the Port of Alaska Hydrogen Pilot Project, we're meeting as a team regularly and still anticipating that the EPA's Clean Ports Initiative is probably the solicitation that is going to be the best fit. And as some folks have been seeing there, the expected issuance date for that solicitation is late February. But during our most recent project meeting, we had some of the PNNL researchers present on the research that they're starting or have been doing, on the formate bicarbonate cycle as a means of long duration hydrogen storage. I have flagged that topic as a potential topic for presentation here because I think there is some value in what they're exploring there and could be a fit for certain applications, but I think it's still kind of early TRL levels. And so they're at the kind of the lab bench level of research. So that's a quick update from my end anyway.
Great, thank you. Any questions for Tim?
Tim, who is that again that's researching that? This is Lee.
Hey, Lee. Yeah, Pacific Northwest National Labs, and specifically Mark Bowden is, at least was the presenter for us last Friday, and he had 3 of his other colleagues who were researchers as well. And then Shannon Idso has been the project lead, or the lead, excuse me, for PNNL engaging with the Port of Alaska team. So she helped coordinate the researchers to come and talk with us.
Awesome. Hey, thanks, Tim.
Mm-hmm.
Other questions for Tim?
Yeah, I have one. Sorry, I'm just finding the raise hand button. Can you elaborate on what the RFP is going to be for late February, please?
Yeah, I'll drop a link here in a second, but that's the EPA's Clean Ports program, under which there's expected 2 solicitations. One is a port program or port-wide program or funding opportunity, and then the other one that's more focused on the heavy-duty trucking within the port space there. And all of that is oriented towards decarbonization, and you can propose different things to get there. Let me pull a link and I'll drop that into the chat because there is quite a bit of information, including recorded webinars, talking about the expected solicitation and all that, as well as eligible costs and eligible entities.
Awesome, thank you.
Yep.
Thank you, Tim. Thanks for everyone's questions. Go ahead, Patty.
From Bob, go ahead.
Okay, go ahead. Thank you.
I'm looking for my raise hand button, but Tim, what's the best way to get in touch with you? Because we've actually a couple of years ago did some work with some port equipment and think it would be interesting for you to be able to reference.
Sounds great. Thanks for mentioning it. I'll put my email address in the chat here.
Okay.
And I raised an idea with Patty earlier, since I know our chats often go away when we close our windows, if we could have a shared document for all of our contacts, for those at least who are willing. But at least for now, I'll put my email in the chat.
Okay, great. Thank you.
Thank you.
Thank you. And thanks for your help, Patty. I guess I must have the wrong view to not see everybody. Any other announcements, projects, developments, challenges? Okay. Well, then I think we will jump into our featured speaker for today, which is Dr. Nathan Prisco from the Alaska Center for Energy and Power. at the University of Alaska Fairbanks. Nathan joined ACEP relatively recently and is a hydrogen specialist, among other things. So his talk today will be focusing on blue and green marine fuel pathways. I think there's probably a few more details encompassed in that title, but Nathan, I'm going to let you take it away and elaborate on your topic from there. And I am seeing your presenter view. So far, so good. And yep, that looks perfect.
Yeah. So thank you, for the opportunity to speak today. It was a bit of a stand-in, so I think that I did include those things that you mentioned, but also a little bit broader in the update. So really today, highlighting, use of hydrogen for grid support. This is something, Justin referred to, how hydrogen can support greater amounts of renewable installations, some pathways for renewable fuels in Alaska, also potential for using sort of the infrastructure we have in hydrogen, and wanted to give just a quick overview of geologic or natural hydrogen, because there's a lot of discussions in the state and projects on carbon storage as well as geothermal. So really, highlighting, the subterranean sort of opportunities for hydrogen, and with an update on Mighty Pipeline, which is a company I formed before joining the university. So, with our color wheel, there's, really a portfolio of options. And really all of these are needed to some extent for decarbonization. And really it's about the emissions reduction, but, this color is useful to help organize thoughts. So, we have black or gray, which are from fossil resources, green hydrogen, which is electrolysis, blue, which involves carbon storage, turquoise, which uses fossil resources to produce hydrogen, but instead of producing CO2, you produce synthetic graphite. Pink is nuclear, and gold or white is natural hydrogen. And just to emphasize that there are clean pathways for natural gas as well as LPG to produce clean resources. One project with ACEP that we've started to look at is really the community value of electrolyzers, particularly in providing grid support. And so this is something that, batteries are quite often used for, but really the challenge is that as conventional power plants are decommissioned, it becomes, there's very little ability to balance power fluctuations. So there's a lot of interest now in actually using these types of electrolyzer systems for grid support. And you can really think of this as another form of storage, but also really complementary and an extra layer of protection to batteries. So what makes this grid forming is combining the pieces of an electrolyzer, a fuel cell, a storage tank, and the electronics for providing that grid support. And just to really look at the storage capacity, even, at a community scale project, 600 kilogram hydrogen tank is about $400,000 and stores 20 megawatts thermal or 8 to 12 electric. So really there's been a lot of sort of DOE FOAs on how can we sort of combine things like electrolyzers, e-fuel plants, or other industrial loads with the grid in smart and sophisticated ways to be able to support more renewable installation. Really so for opportunities in Alaska for hydrogen, one thing that really comes up a lot is the options for the marine fuel space. This is something driven by regulation that Alaska's cruise ship industry, as well as fish processors and other marine industry, is really trying to figure out, how to source or produce, the fuels that they're going to need in Alaska, and just really to try to, organize some of the options we have. We can really get there with power, renewable power and water to energy, or renewable power and waste to energy. Both of these have been modularized, so even it often makes sense to go where the resources are rather than try to develop and existing places. But essentially through electrolysis, you have options to make hydrogen, options to make ammonia, methanol, or even resources like LNG. On the same side, through waste gasification, this is still using renewable power, or in some cases, heat, but instead of water, your feedstock is waste. So really the obstacle here is gathering and drying this waste. But there are many waste streams that can be used in Alaska, including fish processing wastes. But really the challenge is more so than technology, is just how do we as a state identify what waste streams are available and gather these. But ultimately the same types of things can be produced: hydrogen, ammonia, methanol, or instead of LNG, renewable natural gas. And this is similar to some of the projects that have been developed in Hawaii. And really a big focus in the state, I think, is renewable diesel or biodiesel. So just to highlight how you get there, you have some sustainable oil, whether that be beef tallow or oilseed crops or even fish oil. With hydrogen and refinery-like processes, you can make renewable diesel, which is indistinguishable or close to regular diesel. With methanol, you can make biodiesel. This is something that could be done even in a backyard, but limits on how much of that you can use. If you have a refinery-like process, you can also convert methanol into things like gasoline and kerosene. And I think a big opportunity for these types of projects is that similar to the sort of they can provide grid support, similar in ways to power plants. We've had previous presentations on wind resource potential, but again, just to highlight, Alaska has a very strong wind resource, and offshore resources, including wind, are generally stronger near the poles. So there's definitely wind resource available, there's water availability, land availability, and really the challenge for projects is of course you can rely exclusively on wind, but what are other ways you can help provide consistency to the electrolyzer? Also, in terms of offshore, Alaska's offshore resource is very accessible. Many states, including Texas, are starting to look at offshore leases. And just to really highlight that, part of the reason why Alaska has such a strong hydro potential is this shallow continental shelf, which can be a big cost influence on wind projects. One technology that I became aware of recently that I found interesting is INEOS. So INEOS is Japan's largest oil refiner, and they're developing projects in Australia and Texas using an electrolysis technology called direct MCH. So in their electrolyzer, they're using MCH, which is essentially a petroleum liquid, and they're able to produce renewable hydrogen and absorb it into this liquid, and this allows them to transport the hydrogen using their existing oil tankers, as well as storing it in existing oil tanks. And so really one thought that comes to mind is thinking about the challenge of hydrogen distribution in Alaska. We know that many of Alaska's communities have this infrastructure for storing petroleum liquids. So it really, even from, pilot scale projects and thinking about how we can, distribute, renewable fuels through Alaska from hub communities to other locations, being able to use these, existing infrastructure is really strong sort of value there. And really one of the major barriers to these types of storage and delivery systems is the tanks that you need for these materials. I also wanted to, on a sort of different note, back to the subterranean, I haven't heard a lot of talk in Alaska about the the natural hydrogen, but hydrogen is produced underground in geological processes in a number of ways. So it really depends on, what those geologic features are. It can be splitting of water by rocks that have radioactive minerals or an iron-rich rocks. And this hydrogen is generally evolved to the surface, but in some cases can be trapped and in reservoirs underground. Data for hydrogen that has been found is been reported recently. One thing to point out is it's not that there's a lot of hydrogen in this part of the world. It's that really early on, Russia had a theory that hydrogen underground was important to creating oil, and they thought that if they could understand this, they could produce oil. So they were looking for it. Hydrogen generally hasn't been observed in too many other places. One of the reasons for this is that even in oil and gas exploration, the sensors that they use don't detect hydrogen. So it's very likely that we've been using hydrogen blended gas for some time without knowing it. And so while hydrogen is often observed, it can be very hard to find those special conditions that you need for it to be, contained in the ground and produced. And so part of why this is a frontier effort is that it involves exploring geological formations that typically haven't been explored by oil and gas. And just to, as a notable example, in Mali, there was a company that was drilling a water well. They struck hydrogen, and there's a community that has been powered on hydrogen, carbon-free there. And there's active exploration efforts throughout the world at this point. And what's interesting is oftentimes you can see evidence of hydrogen seeps at the surface with what's called fairy circles. So this hydrogen seeping to the surface can change plant growth. It can cause depressions or mounds to form. And often case, if you go on Google Earth, you can see them in Namibia, you can see them in South Carolina and other places. And then I would just want to point out, so ACEP is working on geothermal projects at Pilgrims. And one thing to point out is that there at least seems to be similar types of surface features there. And while I don't have a natural hydrogen company, if I did, I'd look at Seward Peninsula. And to end the talk, I wanted to give an overview of Mighty Pipeline, which is a hydrogen transport and distribution company that really brought me to Alaska and has continued to work on it as I can. But really the goal of Mighty Pipeline is to be able to distribute hydrogen through existing oil and gas infrastructure, really addressing the problem that hydrogen is something that many people are trying to produce. But one of the major barriers is how do we transport and store hydrogen? Also, looking at the opportunities in Alaska, we see that we have very large amounts of renewable potential, but oftentimes lack that transmission interconnect to bring them to markets. And also recognizing the challenge that as oil production is declining, pipelines become expensive to operate. So the approach with Mighty Pipeline is developing hardware and process technology to transport hydrogen in the form of ammonia through oil pipelines for bulk delivery to market. Looking at the U.S. pipeline network, Alaska has the second largest oil pipeline in the world. And I've highlighted refineries in the United States to be either brown as simple refineries, these are only capable of distillation, or H2 enabled refineries. These are complex refineries that have units like delayed cokers and other equipment. And essentially, this is where the vast majority of hydrogen is produced and used in the United States today. So there's, definitely, advantages to being able to distribute hydrogen to these locations, especially in the Gulf, where there's already hydrogen pipelines that can distribute that. So really, the focus is on the midstream piece, because there's going to be substantial amounts of investment needed, and oftentimes midstream isn't a big focus. And in many cases, ammonia can be the most economical carrier whenever you have long distances of transport, as well as long storage times. So really, the problem that we solved is that Mighty Solution is a patent pending process technology to blend ammonia and oil stably so that it can be transported through pipes. And this enhances pipeline ROI and throughput. So really the opportunity, looking at the benefits of ammonia blending into oil pipelines and what this can do, is that a lot of more viscous crude oils are very difficult to transport. In fact, very environmentally intensive to transport. So in the case of Canada, their oil cannot actually go through pipelines by itself. So they import oil from the United States to blend with their oil to send back to us so that we can reprocess it in refineries and send it back to them. So this, adds a lot of cost to their industry, and being able to produce a renewable or carbon-free alternative to that can reduce, that $10 per barrel diluent cycle, but also in terms of those pipelines, essentially 70% of the pipeline is what they're trying to transport, and 30% is the diluent they're using to be able to move that. So Alaska has not had a sort of strategy like this in the past, because there is no diluent market in Alaska, but using clean ammonia as a diluent could certainly help with the resources in our state. And also in terms of bio opportunities, one of the hardest parts of bioenergy is gathering. So being able to use pipelines and transport difficult to move bioresources is a major benefit. So essentially what this does is that we can substantially reduce viscosity and transport any oil through a pipeline, whether or not that pipeline was designed for light oils or other resources. So really as an overview, this allows for transport of oil and ammonia. They can be separated at the terminal using just gravity, so no high, very low carbon intensity. There's benefits in terms of what this can do in terms of oil processing. So essentially, you can upgrade crude oil value. and get things that can be used like INEOS does. So BTX can be used as hydrogen transporters. You can remove things like asphalt. And really, there's companies in Japan that are also interested in shipping blends of ammonia, because ammonia weighs about the same as propane and butane. So using these existing gas carriers, you can transport blends of ammonia and fuels. So ultimately, we're looking at demonstrating, the transport of both by rail, the recovery or the value enhancing of oil processing in a green way, as well as working towards validating those pipeline applications. And essentially, as an overview, it does involve some scope of modification to be able to transport resources like this and hydrogen carriers like ammonia, various modifications to pumping facilities, as well as your storage and recovery facilities. But I will point out that very similar projects have been proposed in the past. So in 1988, there was the prospective Prudhoe Bay liquid LPG project. This was envisioned as an end-of-life recovery. And so they were looking at recovering the LPG of the North Slope, and they were going to do this by modifying the pipeline in a similar way that I just introduced. And ultimately, what they decided is that those resources were better used to enhance oil production, but the benefits of that decision are in entering diminishing returns. And so looking into the future, there are opportunities to recover things like LPG from the North Slope, and for hydrogen, clean hydrogen pathways like blue hydrogen or turquoise hydrogen, LPG can be used as your feedstock to produce a low emission hydrogen. In some cases, turquoise hydrogen can be lower or equal to that of that from electrolysis. And then really just to, you can certainly reach out, if you want to learn more about this comparison, but ultimately it can be competitive with other sources and other places that are looking at producing blue ammonia as a resource. So ultimately, what I'm trying to highlight is that the challenge in Alaska is that projects are going to be very capital intensive, but maybe considering it's a stranded resource, there's less of a feedstock burden. But ultimately, you need some sort of mutual or benefit that can be monetized to support this. So there's tax credits for low carbon resources, but ultimately, this would have to be motivated by, as the throughput is declining, the ability to really reduce the burden on the pipeline operator, who has to try to keep that pipeline maintained with new throughput, as well as the ability to move LPG. And then, just in a long-term perspective, once those investments are paid off, Alaska's cash cost is very competitive to other regions. And definitely would be interested in any questions.
Thank you, Nathan. We appreciate that overview. Thank you. Any questions for Nathan? Raise your hand if you can, please. I see an old-fashioned hand raise from Dave Blue. Dave.
I can't find the hand raising icon here on my on my display, so I had to do it the old-fashioned way. I'm old enough to do that anyway. The question I have for you guys is I've heard a lot about the types of storage technologies that utilize essentially a metallic matrix to store the hydrogen, because it can be stored at atmospheric pressure and atmospheric temperature, and then through a catalytic process removes the hydrogen for use in the load, whether that load is on board a ship or whether that load is for an internal combustion engine. I've heard a lot about these technologies. In fact, in Seattle, there is a company that has been developing one and has done some testing with internal combustion engines. And the advantage of that system, of course, is that it's very simple to remove, and you're removing pure hydrogen. You're not have to address some of the controversies that I've heard about storing ammonia because of the natural toxicity of ammonia. But so could you tell us a little bit about what you know about those technologies in comparison to using ammonia as a carrier?
Yeah, I think that we're probably not going to see things like that on a ship, especially the large ships that are very price sensitive. Ultimately, I think ammonia, definitely has some safety concerns outside of a controlled industrial environment. But at the same time, for Alaska's marine vessels, most of these already have ammonia on board. They use it for refrigeration, and they call it usually an eco refrigerant because it's replacing CFCs. So by switching to ammonia, lots of benefits. I think that ultimately with ammonia, what needs to, and many people with LNG, so liquefied natural gas, they were concerned. They're like, oh, this isn't safe. But what's needed with ammonia is just the equipment and sort of expertise to be able to use it safely. And I think that a lot of the concerns are mainly that, yes, it's used in refrigeration, but we don't really have all the equipment we need to use it, as a fuel. So I think that definitely that's sort of part of the missing piece, is just the sort of industrial demonstrations and development of supply chain support.
Yeah, thanks for your answer.
Terrific. Jason.
Hi there. Yeah, Jason Moncrief with Kaufman Engineers. Quick, easy question for you. You mentioned the cost of the 600 kilogram storage tank. Would you repeat that? What that cost is? You figure?
I think it was about 400,000.
Okay, thanks.
Tim?
Thanks. Two questions. One, I love the comment about prospecting for white or gold hydrogen. I wanted to see if anybody here is aware of entities within the state doing that, or if the state agencies like DNR are starting to consider that. Nate, do you have a direct perspective on that, or any insights?
So I have spoken with DGGS, and sort of to them, that wasn't really on their radar. So I know that there has been people in the past in the working group talking about natural hydrogen, but I think that ultimately what DGGS recommended is that I somehow find some resources and go maybe next time they're doing work at Pilgrims and try to do some soil sampling to see if we can verify those features as a hydrogen seed.
Thanks.
I'll add to,
oh, go ahead.
yeah,
Sorry.
I'll add to that I know there's a lot of interest in naturally occurring hydrogen, and that's a talk we're trying to get on our lineup here, because we do have some members of the hydrogen working group that are involved with that. So I'm just as interested in it as you are, Tim. So thank you for asking. And it sounds like you have another question as well.
Yeah, great. And quick follow-up comment, serpentines all over the state. So there's definitely that process geologically that might, if we have the right formation underneath to capture it, that'd be great. Second question, though, was really related to ammonia in various fuel or use cases, especially for shipping. The PNNL folks flagged for me a paper that I have not yet read, but looking at the potential scale in use of ammonia and how that could disrupt the planetary nitrogen cycle. So has anybody else looked at that to start with that could give me cliff notes? Maybe not now, but for some other time.
Well, I would, really, that's one of the major problems with just agriculture in general. So, in Mississippi, a lot of the runoff goes into the delta. But ultimately, when you have the right sort of ways to handle and move ammonia, and when it's combusted and the NOx is handled appropriately, as because essentially the solution to pollution with ammonia is ammonia, because we have all diesel trucks in the United States have inject urea, which produces ammonia, and that's used to scrub the emissions. So essentially, when you have this fuel, when you have a supply chain and you have the right handling equipment and it's used in a power plant and scrubbed, there are no reactive nitrogen emissions.
Awesome. Thank you.
And we have Paul.
Hey, Nathan, thanks for your talk. Really interesting stuff. I'm wondering if you can speak to the comparison between the liquid ammonia blend that you guys are working on at Mighty Pipeline with the MCH ENEOS project that's electrolysis based, just in terms of how easily it fits into the existing infrastructure, the storage duration, and also like the separation processes for both.
Yeah, so they, in some aspects, the separation, there would have to be changes to oil pipelines to some extent, but they actually, there's a pretty strong connection, because what they're looking at are MCH, so these petroleum liquids, and so ammonia has the ability to pull things like that out of crude oil. So if you're thinking like Alaska, which doesn't have, it's not Houston, so most of Alaska's resource is sold as crude oil. This gives some opportunity to get some more midstream value. So in their case, they're using something like MCH. That has to go two directions. So it absorbs hydrogen, they take it to where they need it, they release hydrogen, they have to bring it back, absorb more hydrogen. In the case of ammonia, you can just deliver it and not have to do that. One of the benefits, I think, of MCH is that it has a very low cracking temperature. So I think they can crack it at like 100 to 200 Celsius, where ammonia generally is a bit harder to crack. I think, either up to 400 degrees. So those are maybe some of the differences.
Great, thank you.
Dave again. You're still on mute. Not yet. While you're figuring that out, I'll ask a question. Nathan, early on in your presentation, you were talking about, fish oil and waste gasification for production of various types of products. What kinds of quantities are needed for appreciable production? And does Alaska have the quantities necessary of any of those feedstocks?
Yeah, and certainly there's a range of technology providers, and there are small scale gasifiers, and this is, I have spoken with some technology providers for small scale gasifiers, really as more of as a village power solution. But so even the small scale gasifiers, typically small scales is about 40 tons per day of waste. So it could only really be used in places where you have very good gathering, or in sort of larger community hubs. Full scale starts to get greater than about maybe 800 tons per day.
And how does that compare with like how much we produce in Alaska? I have no idea how much waste, for example,
Right.
Anchorage produces per day. Does anybody know?
So I had a number you can look up like waste per person, and I'll have to check, but I know the fishing waste, and there is definitely enough. It's just a matter of, can you get it in one location, and how do you do that? So and I think, there's lots of, in general, trying to understand the waste streams. I know there's some forestry wastes and other things that could be used. But what's interesting about the gasification is that it can be carbon negative even without carbon capture, because oftentimes by gasifying a waste, you're preventing it from forming methane into the environment, which has a worse effect. So part of your carbon benefit with gasification is actually preventing things from sort of decomposing.
Okay, thank you. David, looks like you got your mute button figured out. What would you like to ask?
All right. Yeah, this goes back to pulling the hydrogen out of the ammonia for some sort of commercial use. And I think a lot of people are, and you said this at the beginning of your presentation, that this hydrogen is the future of energy, and I firmly believe that. And even though I'm with a nuclear company, we're a microreactor company. We want to power hydrogen production systems with microreactors. But hydrogen is the answer. So what do you, and this may take some speculation on your part, what do you see as the obstacles of using an ammonia hydrogen system to power your typical vehicle? I think we all realize that there are limitations with batteries for all electric vehicles and all the ramifications that produces, and the answer is hydrogen. But what are you going to use how are you going to use the hydrogen in your private vehicle? And so the ammonia aspect is important with that.
Yeah, so Toyota announced that they have an ammonia engine. So they announced our ammonia engine will be the end of electric vehicles. But I definitely agree with you that nuclear is a very great hydrogen opportunity, especially the advanced nuclear, since you can really start to generate the temperatures that you need for hydrogen production. And I think that would be, even as in the state of Alaska with natural gas, I think that'd be a huge sell to the state of Alaska. Is normally when you're making blue hydrogen, you're essentially burning 30 to 40% of your natural gas just to get the energy you need. If you add something in like nuclear, that will extend the resource, by almost 30, 40% longer. So that's would be a good sell.
Yeah, you're preaching to the choir here. Thanks.
Sorry, Lee, go ahead.
Hey everybody, Lee Bowling with Kaufman Engineers. Nate, great presentation, man. This is awesome. I think just one thing to remind everybody too, I don't know if it was said, but the cool thing about ammonia is that you don't need a carbon input to make it, right? So like everything else that we're talking about, whether that's ELNG or methanol or whatever, those kind of carbon-based fuels, you need the hydrogen, but then you also need a CO2 or a carbon input into that. And so you become limited in production by how much carbon you can get, right? So that's what's interesting about ammonia, is that you're not limited at all by a carbon input for it. So from the stuff I've been reading, it seems like ammonia for like using in shipping for large boats and stuff like that is definitely seems to be coming on the horizon. So it'll be interesting to see what happens in the future there. So anyway, I just wanted to share that tidbit with everybody.
Thank you. Thank you. Any other questions for Nathan? All right. Well, with that, I think we will wrap up our presentation. And I, again, thank you, Nathan. That was a great presentation. Really appreciate your sharing those developments with us. I just want to remind everyone that we will not be having a meeting on January 2nd, which is the first Tuesday in January, and we will wait until February. So we'll send out an update about that sometime in the new year. And with that, I will ask if there are any other announcements or things to share for the good of the group. And that includes Patty, if I've forgotten anything. Anything else that anyone would like to share? Oh, I see, Brian, you've got your hand up.
Got it figured. I'm working on a really cool project using basalt rocks, this very specific chemistry of rock that's manufactured into a powder, a fiber, a fabric, and a rigid fiber. It resembles very much like graphite or carbon fiber. It's fireproof to 3,000 degrees. And as a 4 millimeter thick fabric, you can hold a block of dry ice in your hands for up to a minute without it injuring your skin. So I'm looking for someone in the hydrogen market that would like to build some explosion proof, fireproof, frost proof, and technically bulletproof high pressure tank systems. And we're looking at mass producing the material somewhere around $10 a square foot. And we can do 1 million square feet per month. This product is also, if you put it over a person in the snow, they become invisible to infrared and thermal cameras. If you put it on a drone, it becomes invisible to radar. And I'm working with a guy, he's the leader in the world with it. He's been manufacturing it for battery systems in nuclear submarines or diesel powered submarines that keeps the batteries from exploding and causing a fire on the boat. I think it would be great for electric vehicles where you could wrap, or a hydrogen vehicle where you could wrap the fuel cells with the basalt to prevent fires or to control a fire. It's really lightweight, very strong. And
thank you.
Yeah, so if anybody has an interest in that, please hit me up. I think I texted my email in the chats.
Okay, I saw your note there in the chat earlier, Brian. Not sure if I saw your email. I think you just put a note in there, but
I'll put
yeah,
it
go
in
ahead.
again.
Yeah. Oh, bulletproof concrete at proton.me.
Yeah.
Is that it? All right. Bulletproof concrete, all one word, at proton.me. Get in touch with Brian if you want to get in on some of this Star Wars technology. It sounds very exciting. Thank you for that update. Dave.
Yeah, Brian, I'm interested.
Okay, get in touch with him.
Thank you.
There you go. You can find his email in the chat there. And if you don't track it down, just get in touch with Patty and she can make sure that everybody's connected who needs to be or wants to be connected. Any other announcements or updates for the good of the group? All right, well, we're going to give you 20 minutes of your day back. Wish you all the happiest of holidays. Again, we won't be meeting until February. Have fun out there, be safe. We'll see you in the new year. Thank you so much.